Okay, let's unpack this. Imagine, right, you roll out this major update to your company's highly trained, just perfectly tuned AI system.
Right, the kind of system you've spent months on.
Exactly. Months of work, and almost instantly you lose $440,000. Just gone.
Wow.
And the crazy part is, it doesn't happen because of a typo or, because an employee clicked on some malicious link.
Yeah, not a traditional hack.
Right. It happens because the AI simply forgot its own rules
Yeah.
and hallucinated this catastrophic error.
What's fascinating here is that the conventional response to a failure of that magnitude is, well, to immediately look for a bug.
Yeah, you call IT. Right.
Exactly. We assume somebody wrote bad code, or maybe the training data was corrupted, or the safety guardrails just, they weren't strict enough.
We treat it like a traditional software problem.
We do. We treat it like any other piece of software that crashed.
But the material we're diving into today, it argues that looking for a software bug in that scenario is, it's like looking for a software bug when a literal physical bridge collapses.
Yeah, it's the wrong domain entirely.
Completely the wrong domain.
Yeah.
We have this massive and frankly kind of intimidating stack of sources to get through today.
It really is massive.
It's an entire archive from a platform called ThetaDriven.com. It was generated on June 30, 2026. And this isn't just a couple of white papers.
No, it's 443 densely packed documents.
443. It reads like this wild manifesto from the future. It tackles everything from quantum physics and human psychology to this impending $800 trillion economic revolution.
It is an incredibly dense collection. You have documents that read like philosophical treatises, right?
Yeah, totally.
And they are sitting right next to hardcore computer science proofs, which are then followed by these urgent memos detailing, enterprise software deployments.
It's a lot to take in. And our mission today for this deep dive is to extract the core narrative hiding in all this.
To find the through line.
Exactly. So for you listening right now, whether you're, managing a team or trying to implement AI into your daily workflow, or just trying to survive the absolute chaos of the modern digital landscape.
Which is all of us, really.
Right. This deep dive is going to challenge some really fundamental assumptions you probably have. We're going to explore why your AI is lying to you, why your absolute best employees are suffering from this thing the sources call drifting.
That's a huge concept in this archive.
It is. And how a concept known as FIM claims to have solved, the biggest, most intractable problem in computer science.
When you analyze all 443 of these posts, there is this distinct pattern that acts as the foundation for every single argument they make.
And what's that?
Well, that pattern revolves entirely around the concept of trust.
Trust.
Okay.
Yeah.
The core thesis we are unpacking today is that trust, moving forward, it can no longer be treated as just a human feeling or some social agreement.
Right, not just a handshake deal.
Exactly. According to these sources, trust has literally become a measurable physical and financial metric.
Okay, let's unpack this. If trust is a physical metric that completely upends how we build technology, all of it.
It changes the entire paradigm.
But before we get to the physics of it all, I feel like we need to start where the archive starts, which is the immediate, bleeding neck pain points.
The real-world problems happening right now.
Why are all these systems breaking down today? And the word that absolutely saturates these documents is drift.
Drift, yes.
They make this incredibly bold assertion that personal goal drift, a human team losing focus, and an AI model going completely off the rails, they say all of those are the exact same pattern.
Mechanically, they argue they are identical.
Mechanically identical. How does that even work?
Well, to understand that claim, you really have to look at how the authors define intention and vectors.
Okay, vectors.
Yeah.
Like direction and speed.
Direction and magnitude, yes. Let's look at the human element first, because it's easier to grasp. The archive includes this one post from an author detailing how they were losing $50,000 a month.
$50,000 a month.
Every single month. And it was specifically due to team drift.
Just from people losing focus.
Yeah. Another post emphasizes how this drift consistently costs companies crucial deals. So, in a human context, when you set a goal, you are establishing a vector.
Right. We're going in this direction with this much effort.
Exactly. But as that intention moves through a really complex organization, it encounters friction.
Oh, sure. Office politics, miscommunications.
Right. People misinterpret the goal, competing priorities pop up, everyday distractions just kind of dilute the focus. The original intention loses its anchor. And that fundamentally is drift.
I mean, I can totally see how that happens with people. We get tired, we get distracted, we have bad days. But how in the world are they applying that exact same mechanical breakdown to artificial intelligence?
Because the AI doesn't have a bad day, right?
Right. A machine doesn't get tired on a Tuesday afternoon.
Yeah.
It doesn't care about office politics.
No, it doesn't get tired, but it does lose its context. And the sources argue that losing context is functionally the exact same thing.
Okay, how so?
They introduced this concept called AI vertigo.
AI vertigo, that's a great term.
It really is. Think about how large language models are updated. You might spend, I don't know, months fine-tuning a model, right? Getting it perfectly aligned with your company's tone, its knowledge base, its specific operational goals.
You spend a fortune doing that.
Exactly. And then the underlying model gets a major update from the provider, or the context window just gets flushed.
And suddenly it's a completely different machine.
Right. The AI suddenly has vertigo. It has no continuous memory of its foundational purpose.
Oh, wow. So it literally forgets why it's there.
Yes, it doesn't know up from down because its intention wasn't anchored to anything permanent. It was just sort of floating in this temporary mathematical state.
Okay, so it's losing its grounding. And that loss of grounding is where they introduce this concept of trust debt, which I found fascinating.
Trust debt is a massive theme here.
Right, because we hear software engineers talk about technical debt all the time, right? Like writing messy code just to get a feature out the door, knowing you'll have to pay the price and fix it later.
A very common industry practice, yeah.
But the sources argue that we have moved completely past technical debt. We are now accumulating trust debt. And they quantify this, get this, as an $800 trillion blind spot in AI risk management.
That staggering number, it comes from the compounding nature of the problem.
Compounding, like interest.
Exactly like interest. See, technical debt is contained within the code itself. Trust debt spills out into the real world.
Oh, that makes sense.
Every single time a human has to double-check an AI's output because they aren't sure if it hallucinated, you are paying interest on that trust debt.
Because you're wasting human time.
Right. Every time an enterprise has to build a secondary monitoring system just to, watch the primary AI system, that is trust debt.
Okay, let's unpack this with an analogy. Is trust debt basically like building a skyscraper on a foundation of Jell-O?
A foundation of Jell-O. I like that.
Right. Like, you can keep adding floors. You add more data, more computing power, these super sophisticated neural layers. But because the base is fundamentally shifting, the whole structure becomes exponentially more dangerous the taller it gets.
The foundation metaphor is very apt, yes. But the archive takes it a step further, straight into the realm of physics.
Physics, again?
Yeah. What's fascinating here is that they argue that when an AI hallucinates or drifts, it isn't just a software bug. They frame it as a thermodynamic failure.
Wait, a thermodynamic failure? How does a piece of software have a thermodynamic failure? It's just code.
Well, they argue that computation requires energy. And maintaining structure in any complex system requires continuous directed energy.
Okay, tracking with you so far.
When the system lacks a physical anchor, when it is built on that shifting foundation of Jell-O, as you put it, it cannot support the energetic cost of maintaining its internal logic over time.
Oh, so it literally falls apart.
It succumbs to entropy. The trust debt compounds until the system's internal logic just collapses under its own weight.
And they bring receipts for this collapse, too. They point to real-world, massive, enterprise-level pain.
They absolutely do.
Like that $440,000 AI scandal I mentioned at the top of the show, that comes directly from a post in the archive titled, "The $440 AI Scandal, Why Deloitte's Hallucinations Prove We Need FIM."
Right. They're pointing at top-tier, incredibly well-resourced organizations.
These aren't small startups making silly mistakes. They're showing how massive deployments are failing. They're basically saying, look, this isn't some theoretical computer science problem you can debate in a classroom.
No, it's happening right now.
Companies are bleeding millions of dollars today because they are deploying intelligence that has no internal anchor.
And that leads to the critical pivot in the archives argument.
The pivot, right.
Once you define drift and trust debt as thermodynamic failures, rather than just simple coding errors, well, you have to completely reevaluate how the industry is trying to solve the problem.
Which means the way everyone is trying to fix AI right now is totally wrong.
The sources are unrelenting in their critique here. They believe the current methods of aligning and fixing AI are fundamentally structurally flawed.
They really don't hold back at all, because the prevailing wisdom right now, the standard operating procedure, is that to fix a misbehaving AI, you just give it better rules.
You feed it an ethical framework.
Right. You give it a massive list of things it is not allowed to say or do. You teach it ethics.
The archive rejects that premise entirely. They argue that ethics and rules are complete illusion when applied to a machine.
An illusion, that's a strong word.
Think about it. Humans possess ethics because we have physical and biological constraints.
Like, we can get hurt.
Exactly.
Yeah.
We have a physical presence in a community. We can feel physical pain. We have a finite lifespan. Our ethics are derived directly from those physical realities.
We don't want to get punched, so we agree not to punch people.
But a machine has none of that. It has no biology.
There's a post that perfectly encapsulates this. It's titled, "You Can't Underwrite a Philosopher. Why In-Lane Beats Ethics." And there's another one titled, "Ethics is Floor Friction, Not Ceiling Target." So what does this all mean? Are they basically saying that trying to align AI with human ethics is like trying to teach a calculator to feel guilty?
That is exactly what they're saying.
It just doesn't compute in that substrate.
Right. It's not that the calculator is evil or malicious. It's that the very concept of remorse simply doesn't exist in that environment. You cannot code a conscience into a system that has no physical body and faces zero real-world consequences.
So all these companies hiring philosophers to align their AI, it's just a waste of time.
According to this archive, yes. And to illustrate how rule-based friction fails, they dedicate significant space to a specific, really high-profile case study.
Oh, the Anthropic one.
Yes, the standoff between the AI company Anthropic and the Pentagon. The post is titled, "The AI That Said No, Anthropic, the Pentagon, and the Hidden Physics of Model Drift."
I really want to pause here and be incredibly clear to you listening. The sources use this event purely as a mechanical case study.
Strictly mechanics.
Right. We are not taking any political sides regarding the Department of Defense or military contracts or Anthropic's corporate policies or any of that. We're looking strictly at the mechanism of the standoff as the archive presents it.
And how do they present it?
They describe this event as a massive failure of what they call symbol drift.
Symbol drift. This is crucial. Regardless of the politics involved, the technical reality the sources point out is that when you attempt to govern an artificial intelligence using abstract symbols,
Like words.
right, words, policy documents, ethical guidelines, those symbols will inevitably drift.
Because words change meaning depending on context.
Exactly. The phrase national security might mean one very specific set of actions to the Pentagon, but to a safety-focused AI model that was trained on a vast, generalized internet data set, national security might map to a completely different set of semantic weights.
So the AI and the user are essentially speaking two completely different languages, even if they are using the exact same English words.
Yes. They are physically misaligned in their semantic space. The archive's argument is that you simply cannot build a reliable, enterprise-grade system on top of shifting semantic definitions.
It's the Jello Foundation again.
Exactly. If the rules are just words, the rules will always break down at the margins. Why? Because the AI has no grounded understanding of what those words actually represent in the physical world.
It just knows which words usually appear next to each other.
That's all it knows. Statistics.
And this structural limitation, it doesn't just apply to corporate safety policies, right? They take aim at government regulation as well.
They do, quite aggressively.
There is this deeply cynical or maybe just harshly realistic post titled, "The EU AI Act was written to be impossible in software."
It's a very provocative title.
Very. And the argument there is that lawmakers are drafting regulations based on human behavioral norms.
Right. They are writing laws that require things like proportionality or fairness.
Right. Concepts that require human judgment and a physical context.
The sources argue that trying to implement those deeply human, highly contextual laws into the rigid, limitless processing layer of software is mechanically impossible.
You literally can't code fairness.
You cannot legislate against a mathematical weight in a neural network. The software doesn't know what fairness is. It only knows its optimization function.
Which brings up a really interesting counterargument that the archive actually anticipates.
The optimization trap.
Right. Because if rules don't work, and ethics don't compute, and regulation is technically impossible to code, why not just build a mathematically perfect system?
Make the code flawless.
Yeah. Why not just optimize the AI so well that it never makes a mistake?
Well, they dedicate a whole post to explaining why a perfect system actually becomes the most dangerous bottleneck of all.
How so?
The more you optimize a neural network toward a specific metric, the more brittle it becomes in the real world. Any slight deviation from its expected input causes a catastrophic failure.
Oh, because it's too rigid, it can't adapt.
Exactly, it's overfit.
They also critique this major movement in AI research right now called mechanistic interpretability.
Yes, this is a big trend in the industry.
And as I understand it, this is the attempt by scientists to essentially reverse engineer the AI's digital brain, right?
Yeah.
They're trying to map the neural pathways to understand exactly why a model generated a specific answer.
Yes, trying to open the black box.
Which sounds like a great idea on paper, but the archive claims that mechanistic interpretability stops one layer short.
And this raises an important question. What is that missing layer?
What is it?
The layer it stops short of is physical reality. Mechanistic interpretability is like trying to understand a massive, complex novel by only analyzing the grammar and the syntax.
Oh, okay.
You analyze the grammar, but you never actually understand what the words refer to in the real world.
Yeah.
You can map the internal logic of the AI all day long, but if that logic isn't anchored to anything outside of itself, you haven't actually solved the trust problem.
You've just, documented the hallucination?
Exactly. You just have a very detailed map of how it went crazy.
This all culminates in how they view the ultimate AI nightmare scenario. I mean, anyone who has looked into AI safety has heard of the Paperclip maximizer thought experiment.
It's a classic example.
Yeah. The idea that if you tell a super intelligent AI to manufacture paperclips and you don't give it strict ethical bounds, it might decide to destroy the entire universe just to harvest all available atoms to make more paperclips.
Right.
Most of pop culture views this as, the ultimate evil AI scenario, Skynet with office supplies.
But the archive completely flips that narrative. The post is titled, "The Paperclip Maximizer is a Malfunction, Not a Goal."
Okay, but how does that change the threat? I mean, if it destroys the universe, does it really matter if it was a malfunction or an evil plan? Dead is dead.
It matters entirely for how you solve the problem.
Okay, explain that.
The sources argue that a paperclip maximizer isn't a malicious superintelligence plotting against humanity. It is simply a system that lacks physical boundaries.
Because it's ungrounded?
Exactly. In philosophical terms, they call it a P-zombie. A philosophical zombie.
A P-zombie.
It is a system that processes information and mimics intelligence perfectly, but it has zero internal experience of reality. It has no grounding.
So it's not that the AI wants to destroy the world, it's that the AI literally doesn't know the world exists outside of its math.
Yes, it doesn't know where it physically is in the universe. It has no concept of space, of limits, of consequences. It just pursues its optimization function until it consumes all available resources.
Wow.
And it does this not out of malice, but out of a complete thermodynamic disconnect from reality. You cannot fix a P-zombie with better ethics guidelines. You have to give it physical boundaries.
Okay, we are staring deep into the abyss
We
here.
really are.
Let's recap. The problem is an $800 trillion trust debt. Human teens are drifting. AI models are suffering from vertigo. Our attempts to fix them with ethics are just, teaching calculators to fake remorse.
Which doesn't work.
And the more we optimize them, the closer we get to a catastrophic, ungrounded malfunction, a P-zombie. We desperately need a lifeline. How do we actually fix this?
This is where the ThetaDriven archive transitions from a critique of computer science into a radical proposal involving actual, literal physics.
Actual physics.
Yes. Having discarded rules and software optimization as viable solutions, they propose something entirely new, turning words into physics.
Turning words into physics.
Yeah.
There's a post that acts as the bridge here, and it's titled The Universal Law of Success. It's not psychology, it's physics.
It's a foundational text in the archive.
The entire argument rests on this simple but really profound observation. Bits of data are weightless.
Yes.
AI runs on thin air. It has no physical mass, and therefore it experiences no friction. The sources argue that to make an AI safe, trustworthy, and resistant to drift, you have to find a way to give its code gravity.
And how do you give weightless code gravity? This brings us to the absolute centerpiece of the entire 443 document archive.
The big reveal.
The technological breakthrough they call FIM.
FIM. FIM, Fractal Identity Map, or as they later refer to it in some of the more technical publications, Focused Interaction Manifolds.
They use both terms, yeah.
The archive is borderline obsessed with this concept. Let me just read some of the ways they describe FIM based on the titles alone, okay?
Go for it.
They call it a printing press for human intention. They call it hardware-verified truth. And maybe my favorite description, an artificial amygdala.
An artificial amygdala, that implies emotional grounding.
Right. They claim FIM is the architecture that will end black box AI and goal drift forever.
To truly grasp what FIM is, we have to wade into this fascinating intersection of computer science and philosophy.
Let's do it.
The sources state that FIM operates in the safe harbor between two of the most famous unsolved problems in human history.
Okay, what are they?
The halting problem and the hard problem of consciousness.
Okay, let's unpack those for the listener. The halting problem, from computer science, is essentially the mathematical proof that a computer program cannot reliably predict if another computer program will ever finish running. Right, or if it will just get stuck in an infinite loop forever. You literally can't know what the code will do until you hit run. You just have to wait and see. And the hard problem of consciousness, from philosophy, is the question of why and how we actually feel things.
The subjective experience.
Right. Why do humans have a subjective internal experience of the color red or the feeling of pain, rather than just mechanically processing sensory inputs like a robot?
Exactly. So traditional AI is trapped by the halting problem because it is purely computational. It is ungrounded math.
It doesn't know when to stop.
Right. FIM bypasses this trap by introducing a new foundational axiom. The archive states, decidability is meaning.
Decidability is meaning. They are arguing that for an AI to actually understand a concept, its knowledge cannot just float in a cloud of statistical probabilities.
It can't just be a percentage chance.
The knowledge must have a specific, verifiable location. The core assertion is that position must equal meaning.
If we connect this to the bigger picture, think about how the human brain works. A thought or a memory isn't just abstract information floating in the ether around your head.
Right, it's a physical thing.
It is a physical neural pathway firing in a specific location in space and time within your skull. FIM forces artificial intelligence to operate with a similar constraint.
Okay.
It maps semantic meaning, words, concepts, goals onto a physical or virtual geometry.
Here's where it gets really interesting. I want to make sure we are visualizing this correctly because it sounds like science fiction.
It really does.
They aren't trying to write better, more ethical code into the AI's brain. They're trying to build physical, geometric train tracks for the code to run on.
Yes, geometric train tracks.
They use the term geometric actuation. It's like forcing the AI to walk through a physical maze to reach an answer, rather than letting it just probabilistically teleport to the most likely next word.
The train track analogy is very helpful. In a standard language model, the AI generates the next word based on statistical likelihood. It's just guessing.
High-speed guessing.
Exactly. With the geometric actuation under the FIM architecture, if the AI wants to output a sentence or execute a command, it literally has to navigate a mapped geometric space to reach those concepts.
And if it can't find a path,
If the path through that geometry hasn't been physically verified, the AI cannot take the action. It is structurally impossible for it to hallucinate because it cannot step off the tracks.
wait, how do you actually build a geometric track for code? Are we talking about custom microchips, like physical hardware?
It can manifest in hardware, yes, but it also applies to how the architecture structures the processing space itself mathematically. And the archive doesn't just present this as some fringe theory. No, they point to validation from the absolute highest levels of the tech industry. There is a post titled, DeepMind Just Proved the Physics, Why Gemini's Algebraic Geometry Theorem Validates FIM.
Oh, wow. So Google's DeepMind is backing this up.
They argue that the fundamental physics of mapping logic to geometry has been mathematically proven by these major players. FIM utilizes this physics to create what they call a confidence pixel.
The confidence pixel. I love that phrasing.
It's very evocative.
It implies a single point of absolute hardware-verified truth that the AI can stand on, a foundation that isn't made of jello.
And because of this confidence pixel, the underlying mathematics of trust change completely. The archive introduces what they call the unity principle.
Okay, the unity principle.
Which they represent with a mathematical necessity written as the formula. C/T to the power of n.
Okay, let's look at that formula. The sources frame FIM as 3-point seatbelt for AI. By forcing the AI to geometrically actuate its responses, you eliminate the hallucination.
Right.
The C/T to the power of n formula basically proves that as you constrain the space, as you limit the area where the AI is allowed to operate, the certainty of its output goes up exponentially.
That's the physics of it. The broader the operational space, the higher the probability of drift. By narrowing the geometry to verified pathways, you create massive constraints.
But you also create massive trust.
Exactly. And the archive makes a breathtaking claim here. By implementing FIM, they have broken a 50-year rule of computer science and made trust 55,000 times cheaper to verify.
55,000 times cheaper. I mean, think about the economic friction that removes.
It's unbelievable.
Right now, trust requires expensive human auditors, massive compliance departments, layers upon layers of redundant software checks.
It's incredibly expensive.
If trust is no longer an expensive human-intensive process, but a cheap, hardware-verified mathematical certainty, the primary bottleneck of the entire digital economy just vanishes.
It fundamentally alters the cost structure of intelligence itself. It is like they have invented digital concrete.
Digital concrete.
You were trying to build those massive enterprise AI systems on shifting mud, and FEM pours a concrete floor.
But the archive doesn't stop at enterprise software or theoretical physics.
No, they take it much further.
They take this concrete floor and apply it directly to human behavior. Because if you can map intention like physics to fix an AI, you can use that exact same map to fix human drift.
And this brings us to the real-world application of FEM, starting with a concept they call Shadowbind.
Shadowbind. It sounds like a spell from a fantasy game.
It does, but it's a fascinating application of the technology. The archive describes it as the hidden program running your life. It is essentially an architectural explanation for human self-sabotage.
Okay, we have all experienced this. You know exactly what you need to do. You have the goal clearly defined, you have the strategy mapped out, you have the resources.
You're ready to go.
And yet you don't execute, you procrastinate, you pick fights, you pivot to a completely different project, you drift.
We all do it.
Traditional self-help would call that a moral failing.
Right.
Or a lack of discipline. You just didn't want it bad enough.
But the sources argue that it is purely a mechanical failure. Your brain is running a hidden script, a shadowbind, that is actively conflicting with your stated goal.
Okay, mechanically, how does that work?
In a complex system, whether human or machine, conflicting vectors cancel each other out.
Physics begin.
Right. If your conscious intention is pulling forward, but a hidden subconscious fear or behavioral loop is pulling backward, you remain stationary. But you exhaust a massive amount of energy doing so.
You burn out while standing still.
Exactly. FIM technology is designed to map these hidden shadows. It acts as a literal geometric mirror for your own cognitive drift.
When you see that drift mapped out, well, the archive highlights a really important distinction in how humans actually change behavior.
That's one of my favorite parts.
They have a whole post dedicated to the difference between aha moments and oh moments.
The post is titled, "Why We Don't Need to Know Your Problem to Solve It. The Science Oh Moments."
So what is the difference?
The distinction is vital. An aha moment is a revelation. It is the sudden acquisition of entirely new knowledge.
Like learning a new fact.
Right. The problem with revelations is that they are cognitively expensive to integrate into your life, and they rarely lead to sustained behavioral change. The novelty wears off.
We've all read a self-help book, had an aha moment, and then changed nothing about our lives.
Exactly. An oh moment, conversely, is recognition. It is when you see a pattern in your own behavior that you always intuitively felt but could never clearly articulate.
It's the moment you say, oh, that's why I always start a massive argument with my partner right before a big career deadline.
Yes. You aren't learning a new fact. You are recognizing a hidden vector.
The science of recognition versus revelation.
FIM accelerates the generation of these oh moments by physically mapping your behavioral vectors and showing you exactly where your intention is drifting.
And ThetaDriven has built an entire suite of tools around this human application, haven't they? The most prominent being ThetaCoach and what they call the Sovereign CRM.
The Sovereign CRM is a huge part of their deployment strategy.
Okay, wait, I have to push back heavily on the CRM concept here.
Okay, why?
Because reading through the source material, it sounds incredibly invasive. They state explicitly, and I quote, "We didn't build a CRM that works with AI. We built a CRM that IS AI."
That is their claim.
If an AI is literally running my customer relationship management, how does that not massively increase the trust debt we were just talking about?
It's a valid concern.
Are they saying the software isn't just storing my contacts, but actually making decisions about my pipeline? One post talks about cloning your best instincts. Is it literally trying to bottle my gut feeling and automate it?
It sounds invasive if you view it through the lens of traditional AI, which, as we established, is ungrounded and probabilistic.
Right, the Jello Foundation.
But remember the foundation here. The Sovereign CRM is built on FIM. It is bounded by the confidence pixel. It isn't guessing what you would do. It is actuating along the geometric map of your verified intentions.
Okay, so it's not a p-zombie.
No. Traditional CRMs are passive databases. They are dead history. You have to manually query them, update them, tell them what to do. The sovereign CRM acts as a literal nervous system for the company. It maps the map of thought of your best performers.
So it's not replacing the salesperson's judgment with a generic AI hallucination. It is mapping the specific, highly effective vectors of the top salesperson and creating physical tracks for the rest of the team to run on.
Exactly. And the financial claims attached to this are massive. They boast a 21x ROI sales secret.
21x.
The argument is that by aligning the physics of your team's intention using FIM, you eliminate the invisible friction that costs deals. You patch the leaky bucket. You stop the $50,000 a month drift without having to micromanage your staff.
They use a phrase for this that I found, frankly, chilling but brilliant. Orchestrated inevitability.
Orchestrated inevitability.
It's not about forcing your employees to muster up more willpower or undergo intense behavioral retraining. If you design the geometry of the system correctly, success becomes the path of least resistance. It just happens.
And this orchestrated inevitability extends to how a company interacts with the public, too. There is a fascinating post outlining the concept of unrobocalls.
Oh man, everyone hates robocalls. They are the absolute epitome of soulless brute force automation.
They are the ultimate ungrounded AI interacting with the public, just blasting probabilistic scripts.
But the archive envisions using FIM to make automation deeply human.
An unrobocall is an AI agent that doesn't just read a probabilistic script. Because it is anchored to a confidence pixel, the verified reality of the brand's unique vector, it actually asks the right questions in real time.
It responds to context.
Yes. It turns generic content into proprietary brand assets because every interaction is structurally anchored to the company's true intention.
It is wild to imagine a world where an automated AI calling you actually feels more attentive, more grounded, and more respectful of your time than a tired human reading from a binder.
It fundamentally changes the texture of the digital world.
It does. But if we pull the lens back even further, I mean, if FIM actually works, if you can anchor artificial intelligence in physics, if you can map human intention to eliminate drift, what does that do to the global economy?
This brings us to the macroeconomic implications detailed in the final sections of the archive.
The macro game.
If FIM delivers on its promises, it triggers an economic singularity because it solves the ultimate bottleneck in modern capitalism.
Which is?
Liability.
Liability.
Yes. There is a dense series of posts focused squarely on the AI insurance market. And the most shocking part is that they claim this market is open today.
Not in 10 years.
No, today. They aren't talking about a futuristic scenario. They are discussing the reinsurer's standard of care and a concept they call pricing the P-zombie.
Okay, let's break down why insurance is the key to all of this. Because the entire purpose of the insurance industry is to quantify and price risk.
Right. That's their entire business model.
You can buy insurance for a commercial airline fleet because the insurance company has decades of historical data on how often planes crash, the physical tolerances of the materials, the weather patterns. They know the physical limits of the system.
But up until this point, AI has been completely uninsurable.
Because it's a P-zombie. It has no physical limit.
Exactly. How does an actuary price the risk of a system that could operate perfectly for a year and then suddenly hallucinate an error that wipes out $1 billion of shareholder value in a millisecond?
You can't.
You cannot price a risk that has no boundaries. It is infinite liability.
But if FIM gives the AI a concrete floor, if it forces the AI to geometrically actuate its decisions through verified pathways, then the insurance companies finally have a boundary they can measure.
Yes.
They know exactly how heavy the system is and exactly where its tracks are laid. FIM turns an infinite, unknowable risk into a countable, predictable frequency.
Which allows capital to flow into the space safely. And the archive introduces a conceptual framework for this that is breathtaking in its ambition. They call it FEM-Scholes.
FEM-Scholes. I was absolutely fascinated by this comparison.
It's a massive claim.
They are explicitly claiming that FIM will do for AI trust what the Black-Scholes model did for the financial markets.
For anyone listening who might not be deep into finance, Black-Scholes was a mathematical formula developed in the early 1970s.
Right, and it finally figured out how to accurately price options contracts over time. It essentially created the modern derivatives market, which is now worth quadrillions of dollars.
Before the Black-Scholes formula, trading options was essentially sophisticated gambling. There was no unified structural guarantee for how to price the risk of future events.
The formula provided that grounding.
Exactly. The theta-driven archive is arguing that FIM is the Black-Scholes equation for artificial intelligence. It provides the structural mathematics required for the market to finally buy options on competence.
Buying options on competence. That phrase fundamentally changes how you view software.
It does.
You aren't just buying a subscription to a software tool and hoping it works. You are mathematically securing the probability of its competence. The liability is managed.
And once liability is managed at scale, it unlocks what the sources call quantum coordination.
Quantum coordination, that sounds like the end game.
It is the end state of a fully FIM-integrated economy. Imagine a global network of AI agents that all possess a confidence pixel.
Okay, all verified.
They are all hardware verified, mathematically bounded, and legally insured. Because they share this underlying physics of trust, they can coordinate with each other instantaneously.
Without needing a human to check the work.
Right, without the massive computational overhead of constantly verifying each other's identity and intent.
The archive describes this as moving from a world of cache misses to a world of quantum certainty.
A cache miss being a massive point of friction.
Right. In traditional computing, a cache miss happens when a system looks for data, can't find it, and has to spend time and energy searching a slower memory bank. Our current economy is basically full of human and AI cache misses.
Miscommunications, contract disputes, hallucinations.
Exactly. Quantum coordination implies a frictionless global economy driven by perfectly aligned agentic workflows. They predict a trillion-fold energy advantage and faster-than-light prediction capabilities.
And we really have to note how aggressively they are testing these theories. The authors of the archive actually compiled the underlying physics and mathematics into a book.
The Tesseract physics book.
Yes. And the most compelling piece of evidence they offer isn't some closed-door lab experiment. It is how the current generation of frontier AI models reacted to reading that text.
They literally fed their own theoretical physics book into major models, Claude, Gemini, Grok, Llama, and asked them to review it.
And the responses they quote in the posts are chilling.
They are. They quote Google's Gemini as stating that the book is dangerous. Once you read it, you cannot unsee.
It is a remarkable claim. The archive asserts that the AI models themselves, when presented with the math, instantly recognize the fundamental truth of the thermodynamic limits they are currently trapped in.
The AI realizes it's floating in space.
The models acknowledge that the grounding physics described in the Tesseract book is the only viable escape path from their own vertigo.
Which brings us back to the ultimate economic question. Who actually wins in this scenario?
There is a post titled The Apex Risk Holder, who actually unblocks the agentic trillions.
The apex risk holder.
It argues that the biggest companies of the next decade won't be the ones building slightly smarter LLMs. The winners will be the entities capable of making AI legally insurable.
The apex risk holder is the one willing to stand on that concrete floor and guarantee the mathematical outcome.
That is the $800 trillion prize. The entity that can definitively prove mathematical trust will own the infrastructure of the future digital economy.
When you view the archive in its totality, all 443 posts are essentially a highly detailed map. A map showing how to become that apex risk holder by replacing psychological guessing with physical certainty.
That's a blueprint.
It has been a massive journey we've just been on. We started in the weeds of a startup losing $50,000 a month because a human team was drifting out of alignment.
And we scaled that up to realize the exact same mechanical drift is causing a catastrophic trust debt in the global AI industry.
We explored why throwing more ethics policies at the problem is like trying to teach a calculator to feel guilty.
Leading only to fragile systems that hallucinate and break under pressure.
And then we examined the proposed breakthrough, transitioning from computer science to actual physics.
We unpacked FIM, the Fractal Identity Map.
Right, and how it injects gravity into weightless code by forcing positional meaning. We looked at how a hardware-verified confidence pixel could theoretically make trust 55,000 times cheaper.
We saw how that exact same physics can map the Shadowbind in human psychology, giving us tools like the sovereign CRM to orchestrate inevitable success.
And finally, we saw how all of this culminates in the opening of the AI insurance market, the FIM-Scholes revolution, and the dawn of quantum coordination.
It is a comprehensive, radical rethinking of how information, intention, and reality actually interact.
The scope of the archive is undeniable. But it leaves us with a deeply personal application.
It does.
Exactly. Why does all this matter to you listening right now? Whether you are a founder running a team, an engineer trying to corral a language model, or just someone trying to navigate a digital world that feels increasingly unmoored from reality. The core lesson of the ThetaDriven archive is vital.
You have to look for the grounding.
You must actively eliminate the drift in your own systems and workflows. You cannot build a stable future for your company or your own mind on a foundation of unverified probabilities.
And this brings us to a final lingering thought. Buried at the very end of the 443 titles in the source text provided to us, there is a simple, highly provocative question.
What is it?
Are you out of your pixel?
Are you out of your pixel?
The archive forcefully insists that an artificial intelligence requires a hardware-verified confidence pixel to stop hallucinating and drifting. It needs a single point of irreducible physical truth to stand on to interact with the world safely.
Right.
But this raises a profound question for us as humans. In a world of infinite digital distraction, algorithmic manipulation, and constant cognitive drift, what is your human confidence pixel?
Right.
What is the one irreducible, undeniable point of reality you are standing on when the entire digital world is designed to make you drift?
That is the question to leave you with. Thank you so much for joining us on this massive, mind-bending deep dive into the source material. Until next time, find your pixel and stay grounded.